Hello everyone, welcome to Snapmaker tool changes. This time we're going to be doing this in Fusion 360. So if we load up our Fusion 360, we'll start with a clean slate here, and you go out on the internet and like Thingiverse or some of these other places where you can get STL models from. We can download STL models, bring them into this program here, and then do relief cuts in wood with cam tool paths. So let's go ahead and load in our STL. There's two ways you can load in an STL in Fusion 360. One is by going to this Insert tab here and clicking Insert Mesh. And that'll insert the mesh in here. You can pick the plane that you want to set it on. You can pick how you want to tilt it, you want to lean it, you want where you want to put it, anywhere on there, and then it sets it on there. Or you can go over to your tab here and open like a new file from like your hard drive or from iCloud or wherever. There's the reason they have two different ways here is one just opens it up and throws it into a brand new open program here and runs that just the way it is. When you insert a mesh, it loads it in there with other properties, but you cannot edit that mesh because it's a B-rep and not a T-spline. So you have to edit all kinds of stuff to it to get it to where you can manipulate the file to put cam files on it. Cam paths, I'm sorry, on there. So the best way to do this would be to go over here, click open right here. It's going to bring up this window here. What you can do is go open from my computer because you've already downloaded this file. And you want this Fishing Bears file. So we're going to click that one. We're going to load it into Fusion 360 here. Now, like a lot of things, the size and dimensions aren't going to be what you want it to be. So we're going to have to change the size of this to get it down to something small enough that we can cut on the Snapmaker. Okay, here it is. It's all loaded in. So now that it's loaded in, there's a few things we need to do to this. We need to resize this. So in order to check, let's check out and see what size it is. So let's click the top view on our view cube up here. And that's going to be looking straight down, like as the Z-axis going straight down into the center of that. So if you go up to the top of the screen up here, and this tab right here says Inspect, if you click the word Inspect, a little drop down comes in. The first one in the list there is Measure. So we'll left click that. That brings open this little window here. Now how you measure something is you put your mouse on here. Like say, let's find the tallest spot here. So if you notice there's a little circle there next to the mouse pointer. That's what you want to see. So you left click there. That's going to set your first dimension. And then you find the farthest dimension down the other direction here. And you left click on there. Once that comes up, this window will come up here. Make sure your delta is checked. And then this is going to tell you exactly what dimension that is. And that is 266 millimeters wide. From this top height all the way down to the bottom height here. And we'll restart our selection. We can come over here and click on the width part here. And it looks like we're going to have to click all the way over here on this part here. And since you got the delta will go straight across. It gives you the exact dimensions. There's also other ones on here like the distance. That'll be the distance from here to here, but it's like a long shot from like here plus this. It adds a bunch of other dimensions in there. That's why you click the delta here and it tells you exactly what that dimension is. So our Y dimension is 1101 millimeters wide. So that baby's really wide. So if you go up here and click your dial up here, your view cube, you can come down to the front view. We can run our mouse wheel and zoom in on this, and we can look and see how wide this is. Let's reset our selections. Click up here, click down here. You see in your Z, it's 800 millimeters thick. So that's well beyond the size of the Snapmaker. So let's close this out. We'll go back to our regular view here. This house view brings up this view here, which is nice because it gives it like a cross-section view, like an angle. You can see a lot of depth and stuff with it. I like that view a lot. It's a good default view. Any rate, so we're on here. We need to change the size of this. So what we're going to do is we're going to left click on this. It lights it up so that it's selected, turns it colors. So mine is blue. I believe yours will be blue too. I think you can change the colors of those as well, what things are selected or not. But that's another issue. So it's selected. Go up here to where it says modify. Select left click that. You want to scroll down this list here to where the word says scale. And what that's going to do is going to change the size of this. So left click your scale button. This brings up this tab here. Here's the scale. You want the biggest thing on here is you want to make sure that this says uniform, because that's going to shrink this down in all directions in your X, Y, and Z at the same time. Now I already know about what size I want to make this. So I want to set this. This number right here is a whole number. So it thinks this is a whole, like 1. So if you want to say you want to make this half the size, then you would change this to like 0.5. So that's half of a whole. So that will cut this in half. And so on and so on. But I'm going to make it at 0.02. And then select OK. Now you wait a second here. This stuff will go away. That means it's done calculating and doing what it's doing. And then you can zoom and do whatever you want. Okay, we're all set here. I'm just going to click my house. It's going to bring it in nice and quick up here. I'll click my top view so I can look on it. If it gets screwed up here like this where it's not in the right view, there's arrows around the cube here that you can click that will spin that. So there we go. Now we're going to measure this again. So let's go up here. We're going to select inspect. Select measure. Remember, when I say select, that's always left click. Go down on here. Let's click on a spot here. Let's click on a spot here. Make sure our delta Z is. Now you notice that our X now is 97 millimeters from this point here to this point here. So it's just under 4 inches, a little over 3, between 3 and 4 inches. Okay, let's reset this. Let's go and do our width again. Let's click here. And we'll click up here. And we can see our Y now is 69.9 millimeters, almost 70 millimeters. So it's just under 3 inches. So you got basically a 3 by 4 inch piece, more or less. And let's do the Z axis. So we'll click on this little arrow here. It'll spin it to the front. Reset our measurements. Let's zoom in here. We'll go up to the top up here. We'll click up here. And then we'll click down here. 16.046 millimeters. So, you know, that's a little less than, what, a half inch there. So that's pretty good. I think we're going to stay with that. So we'll just hit close because it's just a measurement. You can go back up here and hit your little house here, your home position. Now that we've got our bear to the, or our project here to the right size that we want to cut, let's go to our design shop. But before we do that, let's save this. So if we have any problems, we don't have to go and do that all over again. A nice thing with Fusion 360 is when you make a save, it will save different versions. So every time you save, you're able to put a comment in there so you know what that next save is or whatever, how you want to place that. So it saves all those. So you can change to any version that you want or any save that you want that you've done. So if you've messed up, you know, and you can go back 2 saves or whatever before you messed up and start all over again. It saves a lot of time. So we'll go up here to File, and then we'll click on Save. Now, since you haven't saved on this yet, it's going to ask you to save it as something. So I am just going to call this Fishing Bears. And I want it all one word, Fishing Bears, just like that. And then I'm going to hit Save. Okay, now that's saved. We can do whatever we want. We can get out of this. We can come back tomorrow, load this back up, and it'll be exactly this size right here, 3x4 by about a 1/2 inch. So now we want to put cams on here, tool paths and all that. So let's go up here and we're going to click our design button. We're going to scroll down here to where it says manufacture. We're going to left click on manufacture. That loads up our cam tool area here. In this area here is where we're going to add multiple tool paths. So on the first cut, your first cut is always what they call a roughing cut. And a roughing cut, the only purpose of your roughing cut is to remove excess material that you're not going to use. It's used strictly for speed, for speeding up the job, you know, speeding up your cut, the process of cutting this whole job. Because if you cut this with a small bit, say a 1/8 bit or even smaller, this is going to take hours and hours to cut. Even as small as being a 3x4, because of the layering that you have to do in order to whittle this down to a 1/2 inch, because you can only take up so much for each cut. I'm going to use a 1/4 inch bit. I suggest you purchase a 1/4 inch flat end mill with 2 flutes. You want the 1/4 inch shank. That way you can be able to mill this the same way I'm doing. It's a lot quicker. You'll remove a lot more material, and it's going to save a lot of wear and tear on your machine. So based on that note, the first thing we need to do on here is we need to set up our stock. We need to tell this thing, this computer here, what piece of material, size, shape, and all that, and locations of our home positions and da-da-da-da-da that we're going to save. So what we do is we go up here and click this save button. Once this pops up here, this is going to put a generic default setting on here. We can change all this. So this is your little setup dialog right here. This is your setup box. This little shadowed box on here represents your stock that you're going to cut this out of. This represents your start position. This little, I forget what it's called. You know what I'm talking about. So you can move this around. See all these little circles on here? You can pick whatever starting spot you want. So based on all that, we're going to start from the very top up here. This says machine. On your first tab here, your setup tab. This says machine. Since I only run the Snapmaker machine, I never set up the machine in Fusion 360. You really don't need it unless you run a bunch of machines with all these different types of setups and different types of tools and different types of everything. That's when you will need to set up something like this. Otherwise, the same thing's going to come up every time you run this program, is what you want because you're running your Snapmaker. So based on that, we'll just leave that alone. Go to your setup. Your setup needs to say milling. If you click on this, it'll have a drop down of several different things. Your turning, your cutting, and your additive. Your turning is going to be like lathes, also be your rotary. Your cutting is going to be like plasma torch, your laser operate cutters, stuff like that. Your additive is going to be your 3D printers. So we want to do milling because we're doing CNC work here. So we make sure that says milling. The next box down here is the coordinate system on here. That's what this is, your coordinate. So we want it to say model orientation. We want it to say the stock box point, and then it'll highlight this up so that you can pick whatever spot that you want on here. So I want to pick the lower left corner of that's going to be my home position. So if you click the top spot here on your cube here, on your view cube, and then position it so you can see it. This is how you will see it on your machine right here. So this says top so you can read it. Then you can see this like here. It's going to cut just like this. So this is going to be my lower left corner. So that's going to be my start position, my home position. When I start the program to go cut, it's going to start from right here and then come up and go wherever and cut. So based on that note, we're going to go to the next section here. It says model. You want to select your model. If this isn't already selected as a mesh, come down in here and select your mesh. You might have to click on a few spots around here to get it to select. You might have to go up underneath here. But once you, let's do this. I'm going to exit it out here so I don't have nothing, and then I'll go click it. There. So it was already selected, so it wouldn't let me reselect. So you select it so that your model shows up there. That's the only thing you have to do on here. Fixture, you don't have to worry about that. Go to your stock tab here. Left click. Now what this is going to do, this is going to determine the size of this box. Okay? So always on the top, well actually let's start at the top here. The mode. The mode is a different types of box you want to do. There's either a square, or there's a tube, or there's a round, or there's a solid where actually it'll conform to the shape of your item. So I want a relative size box, and I want it to be able to add to my box. So you can select this, either add. There's a couple different options. We want to add to the sides and the top. You can also have it add to all different sides, and it'll give you an option on here to add a little bit to every side on here. But we only want this. And what I want to do is I want to make sure my top is a little bit larger than my part here. Now see, this really doesn't matter for your actual stock piece that you're going to cut this out of, because you're going to have a bigger piece than this anyways. So this is just for generating your tool pass. It's mainly confines your tool pass within this little area. So based on that, we have our stock offset. This is going to be the sides. That's going to be all the way around at once. So if you change this, you see the box grows. See, now we're 5 millimeters bigger all the way around. So I'll put this back to 1. And that is basically about it. You know, they're all pretty self-explanatory on here. This right here, this is the dimensions. This is important because this tells you basically how big of an area that you are going to cut with your Snapmaker. So you're going to need at least 100 inches wide, or millimeters wide, 72 millimeters in the Y, and you're going to need at least 17 millimeters in your depth there, your Z. So that kind of gives you an idea how big of a piece that you need. So you're talking about a 3 by 4 by half inch thick. So once that's all done there, we don't have to worry about the post process, because all this information you're going to end up entering someplace else anyways. So you can enter it here or enter it somewhere else. It doesn't matter. We're just going to hit OK. That's our setup. Now we have our setup piece all set up, ready to go. Now it's time to do the dirty work and add some tool paths. The kind of tool paths for this kind of cutting is going to be two types. You're going to have some type of a roughing, and then you're going to have some type of a finish. Basically, this is a 3D shape because you got your length, your width, and then you got your height. So based on that, we're going to want to do a 3D type cutting. So we'll go up here, we'll click our 3D adaptive cutter here, where it says 3D adaptive clearing. These are all actually all the different types of, cutting styles that you can, cut on here. They all do something different. If you put your mouse on there, they will show you what they do. Basically, if you see this line on here, everything below this line is pretty much a finishing deal. Everything up here above the line is pretty much a roughing. So basically, we're going to want your adaptive clearing. So we'll left click that. This pops up your little pop-up menu here that says adaptive. And that's going to tell this what, how, and where to cut and what to use. So we'll just start right at the top. Where the first tab here is your tool tab. We need to select what type of a tool we're going to use. We are going to use a 1/4 inch 2-flute flat end mill with a 1/4 inch shank. So we'll hit our select tool. If you've loaded up your tools from the Snapmaker website or Facebook page there, wherever they've got them on their, actually it's on their download section of the snapmaker.com website there. You can get all the stuff to do all your tools in here and for your post. So obviously you've done that if you've reached this far. So I have added a tool in here for my 1/4 inch already. You can do the same. Basically all I did is I went over to my tool library over here and I selected a metric one, and then I changed it, edited it to the size and the shape and everything of the tool that I have. That I will run another quick little video on how to create special tools in Fusion 360 at a later time. But at this point, we're just going to go ahead and click on our 1/4 inch flat end mill and then click select. Okay, once we have that on here, it will place, if you've noticed, a tool on here. Here's your tool with the tool holder. And that's showing you right where it's going to start from. Remember, I clicked the corner of that box right there, so that's where it's going to start from. Okay, so back to our tool tab here. We've selected our tool. The very next thing is Coolant. We don't run Coolant on the Snapmaker, so this must say disabled. If this says anything else on here, I don't know if it's going to do anything or not. So just make sure it says disabled. Down here is your feeds and speeds for the particular tool that you are cutting with. I am cutting with a 1/4 inch 2-flute flat end mill. And with that one, I can travel speeds of anywhere from 1,000 to 1,500 millimeters a minute. And I like to travel this one right around 1,500 millimeters a minute. So I make sure you're in your cutting feed rate. Change that to 1,500. Now this will make your cut feed at 1,500 wherever it's going. Once that's all set, that's all we need to do on this tab here. We'll go back up to the top here. We're going to go right down the list here. The very next tab is geometry. Left click geometry. Now, what geometry does is going to select areas around for your machine. It's going to select boundaries. It's going to select your model. It's going to select heights and other things. So on here, let's start the first one. It's called geometry. What we need to select in here is silhouette. So I'm going to select silhouette. And what that does is it basically selects your shape of your model, and that's the way it's going to conform more or less the tool path to. The next drop down is how it's going to cut. Is it going to cut on inside of your tool line of your path? Is it going to cut right on the path? Or is it going to cut to the outside of the path? What we want is we want to center on the boundary or center on the path. An additional offset is going to add to the outside of your part. So you see this here, this boundary that goes in here. Let me click on the top view here. This boundary that runs all the way around your part here. What it would do is it would extend it out away from that, whatever this amount is. So if I go in here and extend this out to 7 millimeters, my tool is a 6 millimeters, so I extend it out a little bit wider than my tool. It's going to create a little bit wider silhouette path all the way around this. Now you can go even wider and it would expand it way out. You can change the shapes of things and make this a square and cut out this entire square. Well, if you cut out this entire square, that's going to add a tremendous amount of time onto your cutting. Just be prepared for that. There's a lot of different options that you can do and change with this. So I'm just giving you a basic, quick view of how to put something in here, throw some tool paths on it, and cut it out on your Snapmaker with multiple tool changes. So based on that, we're back here at the additional offset of 7 millimeters. That's going to give that path around here a little wider. That's all we need for there. The next option here is stock contours. We don't use that for relief cutting. That's made more for box type shapes or shapes that are squares with holes and notches and ledges and all kinds of other things that are in them. So you can select specific areas on your project to cut and not the entire object. We want to cut the entire object. So we are going to unselect stock contour. The next box here is called rest machining. Rest machining is exactly what everybody's been asking for. This is where you set up your multiple tools. The first thing you have here is a source. The source is basically how and what it's going to read from. Since this is the very first cut that you're making, your roughing cut, you want to make sure that you have from setup stock. So it knows that you're taking a stock blank piece of wood and cutting this out of. The other option on here that we will use, but on our next bit, will be from previous operations. So it knows that there was some machining done prior. So basically on this note, we want from setup stock because this is the very first thing we're doing. The next thing on here is called adjustments. And we want this to be set at ignore cusp. And what that means is if you have this checked as used as computed or machine cusp, what it's going to do is it's going to take your bit, let me zoom down in here, and it's going to try to come down in here and get all these little areas that are all detailed like around the mouth, the nose, the hair, and everything with your large bit. And it's going to add a tremendous amount of time on there and unnecessary cutting that you do not need. We need to remove material and remove material only and not do any kind of fine cutting. So we want to make sure this says ignore cusp. This adjustment offset, just leave that at 0.05 millimeters. That is one of the most best settings that you can have. And what that is if for some reason this calculates somewhere, some possible way in your drawing somewhere where an area where it might cut out one of the little smaller areas, it won't cut too deep. It will make sure no matter what, it's going to leave 0.0 or 0.5 millimeters left, no matter what. So we'll go on to the next thing. The next thing is model. We want to check the model. And then we want to make sure we select our model so that it hides up here as mesh. Just like that. Okay, once that's all done, let's go to our next tab. Our next tab is called heights. Now, what heights is, this is for, tells you everything about your project. Tells your top, the bottom of your pieces. It tells your travel heights for your bit, all kinds of stuff. So if we click our front tab here, our front view on our cube, let me shrink this down here and show you here. Okay, see these lines? These lines represent these boxes here. The bottom box here is actually the bottom of your stock. This next blue line right here is going to be the top of your stock. The next line up here is actually going to be where your tool clearance is at. So say you're cutting over here and it gets done cutting over here and it wants to come over here and cut. Instead of just driving through all your material here, ruining your part, and then cutting over here, it will lift up to this spot, travel along the line, and then come back down and cut over here. This is like a safe clearance so your tool comes by, doesn't hit any of your part. It is very important that that stays above your part. I like a nice 5 millimeters. It's not too high and it's not too close. If you get it too far, then you spend a lot of travel time going up and down when you go in between cuts. So we'll just leave it at that. The next line up here is going to be your clearance height. And what that is when you start and finish a job, that's basically where the tool will go. So we're not going to mess with any of these. We can leave all those default settings. We'll go to our next tab. Our next tab is our passes tab. This tab here has actually all the fine settings for our tool. We're going to describe how your tool is going to cut. So most of the stuff on here you will not use for what this is, but I will kind of explain some of it. Your tolerance, never touch this. Basically what this does, it affects the cutting path of your tool. So your tool is following along the path as it's going around. It is allowing 0.1 millimeter of variance from that line either way. So if you put your mouse on here, you'll see a little picture of it and you'll see what I'm talking about. Just leave it like it is. It's fine. It's nice and tight. It's good. You don't need anything major because it's just going to add a lot more cutting time on here. And this is wood. It's very forgiving. You can have a lot of flaws and a lot of mistakes in here and you'll never even see it. So we'll scroll down to the next thing. It says machine shallow areas. We do not want to machine our shallow areas because that's kind of like our cusp on the other tab. We don't want to do any of that. We just want to remove material, so leave that alone. The next is optimal load. What this has to do is how much pressure that you're putting on your cutter. In order to keep the tool from chattering, it allows so much movement around on your cutter. So this kind of keeps a little contact against the wood at all times. Just leave it alone. The default setting is perfect. The next thing here is a cut to like different directions it's going to cut. I don't use it. You probably could. It's just going to change the pattern of how it cuts and stuff. It may speed it up, it may not. Like I said, I'm just giving you a rough estimate on how to do this. You can come back in later and play with all these settings at your own leisure. So the next thing is your minimum cutting radius. Again, this is something that you don't really mess with on something like this. This is more of if you're cutting like pocket style cutting, where you're going into a corner and your bit is too big for that corner, so it will not go into the corner. But if this is low enough, this number, it will actually try to force its way into that corner to meet that demand. And it will either move your part, damage your machine, or break your bit. I suggest you just leave this alone. I'll show you a little picture here of what it looks like. And if you notice down in the corner, the one corner is round and the other corner is pointed. One of them doesn't, the pointed one has it set at 0, and then the one where it's rounded has a number set to it. We're set at 0.635 millimeters. That's perfect for a 1/4 inch bit. Leave that alone. Again, here's another machine cavities style button. We do not want that checked because, again, that's going to try to machine out all these little holes and everywhere it can possibly get. All we want to do is just rough this bad boy out. So we're going to uncheck machine cavities. Next thing is going to be a direction. Again, it's like your direction up here. It's a different style. You have a conventional and a climb. If you put your mouse button on any one of these, it'll bring up a dialog on here and explain to you what that does. Just leave it on climb. Climb is fine. The next thing here is your maximum roughing step down. This is very critical. This is the amount of material that this is going to rough out or cut out in a single pass. With a 1/4 inch flat end mill on the Snapmaker with a weak bed, because our beds only have support in the middle. So in the y-axis, the bed flexes quite a bit. You can get a lot of vibration if you try to cut too deep into your material, and that will destroy your Snapmaker, and that is a very bad thing. The max you can cut with a 1/4 inch end mill is 1 millimeter to 1.5 millimeters max. If you ever go past 1.5 millimeters, you're on your own. You will vibrate your machine to death. You'll wreck all the guides and everything, and do not do it. So, based on that note, I want to take a 1 millimeter cut with my 1/4 inch flat end mill. So that's 1 millimeter deep. Your final step down is after it's milled all the way down to the bottom. Usually there's a little bit left over. It will try to do the final step down in that amount. I don't want that. I want it to be a little bit bigger, so I'm not taking all day trying to mill out the last little bit, because it'll do it in a couple passes being that small. So we'll just change this to 0.5 millimeters, so it's a 1/2 millimeter. Flat area detection, you do not want to check that. If you check this, it will ignore your step downs and it will mill straight to the bottom and try to mill all that stock out at once. It will bust your Snapmaker. It will bust your bit. It will bust your table. Do not do it. You can do this in certain tools, like in a finishing tool, you do a flat area detection because you do not have all that material in the way to mill out first, because it's already gone. But that's in another step. So back to the next one, the minimum axial engagement. That's another thing that has to do with how much you can make the blade, or the bit I should say, contact the material. Leave it right there. It's just fine. It's not going to hurt nothing. These two options here, order by depth and order by area, has to do with how and where it's going to start cutting and finish cutting. Order by depth will pick areas and by depth and cut that. So it could go over here and start at the very bottom and then come over here and start at the top, and then come over here and want to start at the bottom. You don't really want that on something like this. So, but what you do want is order by area, because when you click that, what it's going to do is, instead of, like, if you don't have it checked, it'll cut a little bit over here and then raise up and move over here and then come down and cut a little bit here and raise up, move over, come down, cut a little bit here. Now you got all this travel time going back and forth, back and forth, back and forth. If you do it by area, it will machine everything over here before it moves over here and before it moves over here. So it will gradually work its way across your part. The next area is stock to leave. This is another section that is very important if you're doing multiple tool changes. Since we need to have this checked, and we want to leave some material left over for our final pass. Since we're going to using a small bit for our final pass, we want to use a small amount, just the smallest amount we can leave on the material. 0.5 millimeters or a half a millimeter is perfect. So we'll leave that just like it is. Don't worry about the fillets, because we're not doing fillets on this. Smoothing, we can check the smoothing because it'll kind of smooth out your cut a little bit, and it'll make it run not so rough when it's doing it. So I like to check that. And I also like to check my feed optimization, because what that does, that will reduce any kind of speed in the corners. So if it's cruising along here and it's going too fast to a spot where it's got to lift up, it'll slow down, lift up, and then speed back up after it clears that spot, so it doesn't crash your tool. It definitely helps. So on there, that is everything that is on your passes tab. Now let's go to the last tab. The last tab is called linking. The linking tab is where all your clearance is at, where all your lead-ins, all your ramping, and where you can start and stop positions if you would like. The only thing on here that I've ever messed with is going to be my ramp. And what that does is, when you take your bit and drive it down into your material for the first time, it makes your first initial cut. It ramps down into the material. There's several different types. There's Helix, basically, and there's a plunge, basically. There's other types, but that's more or less what they are. And this is what they do in a nutshell. Plunge drives straight down in there like a drill bit, like you're drilling a drill. Helix will circle around in a little circle, moving down little by little every revolution around in a circle on a predetermined path. You can tell it how high, how fast, how big the circles are with that. That's what this is here, your helix. So if we do your helix, and then your ramp angle here is going to be the angle of your thread. So think of it as like a thread that's going down into it. We want our threads to be as wide as possible. Otherwise, you're going to have like 15, 20 revolutions, and it's going to take like a whole minute to go down there. So we're going to stretch that out a little bit. Let's change this to 15 degrees. Don't worry about your ramp taper angle. Just leave it at 0. This is another one that you want to change. This is your ramp clearance height. What that does is how high above your part it's going to start doing the circles. We don't need it 2.5 millimeters up. 1 millimeter is plenty. That being said, we can leave everything else just the way it is. Now it's time to see if this baby's going to work. So before we move this around here and click that, I'm going to click my home position so I can watch the tool path form. We're going to click OK. It's going to do a bunch of math, and it's going to think about it, and then it's going to start placing the tool paths on here. This could take a few minutes. So let's see what happens. Okay, and now we have our tool paths. We can look at them. Let me click on the front view here, and now you can see every tool path is in here, all the levels. Everything looks good. So we'll click our home. Now, one thing we need to do here before we move on to the next step is we need to verify everything come out okay. Make sure our tool paths, make sure there's no collisions, like our uh, bit hitting our material or clamp or something. But we're not going to do clamps in here, but it's mainly going to be for your material. So if you scroll up to the top up here, this little button up here, it says simulate. We click on that, left click. It's going to open up your simulate tab. On this tab, you have three little tabs on here. The first one is display. The top one is for your tool. It's basically going to show your tool on here cutting. You can either have it on there or not. Your tool path. This is another thing. If you're, once this simulation runs, as it's cutting, if you have this checked, it will leave lines on here of the actual tool path that it's cutting. I don't like to do that because I can't actually see the material being cut, but you can do it if you want. There's several different options for that. This is your stock. This is what this is going to look like. I have it set up as a standard mode operation and set up as plastic vinyl. So when it cuts, it's going to look kind of shiny. This is another thing that's very important on here. It's called stop on collision. If you check this, if there's an error in here, a collision, it's going to stop the simulation. So you'll know right away that there's a problem. We go to the next tab. It's called info. This tab here will display everything about what's going on. The first one here is the position. This is the position of the cutter during cut. Like actually when it's cutting, that's going to tell you exactly where it's at on your machine when it's cutting, how fast it's going, whether it's doing a rapid feed, a normal feed, what type of movements, and so on and so forth. The operation, it's going to tell you exactly what type of cut you're doing. You're doing an adaptive cut. Down here for the machine, remember earlier, we never set up a machine. So this is going to be blank because we didn't set up a machine because we are only using one. Down here is your verification. This is going to tell you if you had a collision or not. This says none. It says we didn't have any collision. So that's great. The last tab on here is your statistics tab. And it basically tells you how long it's going to take and how much cutting distance there was, and so on and so forth. Go back to our display tab if you want. I'm just going to move this out of the way because right down here in the center is going to be the run for the simulator. Basically, you can just click the play button and it'll start cutting. And it'll leave all these little marks in here just like it was cutting. And you can speed this up and you can slow it down. And this is, or whatever, this is basically going to show you how this is going to cut your piece of wood. This is exactly what you want to watch. You want to make sure that this is going to come out exactly how you want it to come out. You can move all around your part, do whatever you want as it's cutting. It doesn't matter. It'll continue to run. You can even go even faster. You can zip it all right down to the very end here. We're going to go all the way to the very end and see what it looks like. There. That's what the finished model should look like right there when we get done cutting with this first bit. Don't mind these big towers right here. That's just because of the size of the stock that we picked. You're going to be picking a much bigger piece, so this is all going to be solid all the way around. So that looks good. We'll close our simulator. That's our piece there. That's our first bit. Our first bit is done. Now we want to do our finishing. So that's where a different bit will come in. So now to add another tool path on here and to continue basically right where we left off, you just go up here and click on another tool path. This time we want to go up here, click on our 3D tool path, go down the list here to this one that says Morphed Spiral. And basically what that's going to do is throw a spiral contour that is going to blanket over your entire project. and it's going to hug every contour, nook, and cranny. And it's pretty damn good and very powerful. So we'll left click that. Just like as in the first tool, we're going to do the same thing. We're going to run through this entire list, the same thing, except we're going to set it up for a different shape tool. So on this one here, we're going to select our tool. This time, I want to use a small one, a 1 millimeter tapered ball and mill. It has a 1/2 inch radius on the corner. You don't have to have one of these. You can use any bit you want, but this is the bit that I'm going to use. So I'll select OK. Now, just as before, it's going to put it right in the corner, right where I told the home was. We don't have to change anything. Go up here, make sure your coolant says disabled, just like the first bit. Now this bit here is a lot smaller than that 1/4 inch bit. So you can't go as fast as we had on that other bit. The 1/4 inch bit, we were traveling at around 1500 millimeters a minute. With this bit here, you can do around 500 to 800 millimeters a minute. So we're going to pick 600 millimeters a minute. And that's all you need to do on here. The rest of this stuff, these default settings are just fine. Go up here to your geometry tab. Just like before, we're going to select our silhouette. We're going to make sure our tool's in the center. And this time with an offset, we're only going to give it a couple, because we don't need to go all the way out to the wall like we did before. We just need to go down around the sides and maybe just a little bit past so we can get everything on the edges. The contact points and the boundary, it doesn't apply to this. And the contact only would be to go as if like this had a big hole in the middle. Say this was a giant donut. Instead of it going across and then trying to cut out the donut hole, it'll skip over it and not cut that area at all. So we don't really need it. It doesn't apply here because it's nothing on here. Slope. I like to have the slope on there because what the slope does is, I'll show you the picture. It basically cuts on the angles. And the degrees tells you about what it's going to do. So if you have it 45 to 90, it basically does the top. If you have it 0 to 45 degrees, it will basically do the bottom of the slope. And if you have it from 0 to 90 degrees, it will make an attempt to do the entire slope. So I leave it set from slope angle 0 to 90, and I have that checked. Now, just like as in before, this is a second tool change, so we have to make sure that we have the rest machining turned on. Now, before we had it set as in set up from stock. Now we want to do from previous operation. From previous operation, that means there was a cut before this one, so it's going to try to follow right after the first one. And since you ran that first one already, you know that this is going to follow because it's in the same one. They're right here. So we want from previous operations. And now this time, instead of ignore cuss, we want to machine cuss. Because we want it to get down and machine every little nitty gritty hole and every little crack and nook and cranny that's on this. Come down here to the next one and select our model. Make sure we click on our model and it says mesh. Once that all set, we're not going to do the avoid touch surfaces because there's nothing to click on here. We're going to go to our next tab, our heights tab. Again, just like before, this has to do with the heights of your model, your travel heights, your clearance heights, and stuff. We're just going to leave these set up just like they were before. They're absolutely fine, the default settings. Click your passes tab. Now this is where we can set the detail basically you're going to put into your part here, into your project. The first part is your tolerance. Like before, it's basically the line, whether it varies to or back and forth off your line is your tolerance. Just leave it set at that and everything will be just fine. Here's a couple different options you can do here when you're cutting. You can either have it set so it will start, basically it's going to start in a spiral and it's just going to work its way around somewhere. You could either have it spiral out from the middle to the outside. You could have it spiral from the outside to the inside. There's a couple different options in here. Or you can do like a shortest machine distance. I like to do the shortest because then it will do the least amount of cuts to get the same process. Less travel time. Next thing you want to do is you could either make it go clockwise or counterclockwise. I like to do clockwise. It's easier on the tool. Your step over. This is very important. The step over has to do with how far your tool will move over for the next cut. This will determine several things. One, the smaller you make this number, or the smaller your step, the better your picture is going to look. Because if you leave this at default right now, once this is all done, this is going to have a bunch of spiral lines on here that you're going to see. Now, you'll still see all the detail, but it'll have all these lines in it from the tool. It's called tool marks. So basically, a good rule of thumb is about 10 to 15% of your tool. So 10 to 15% of my tool is going to be down around 18 or so. So we'll crank this down. I'll even go one more. We'll say 16. Okay. Now that's only going to move 0.168166 millimeters over on my tool path every time. So it's going to take a lot longer than what it was set up before because it's going to make several passes for that one pass before. And this is going to make it look really smooth. So we'll do that. The direction both ways is fine because it's up, down, wherever it goes. I don't set the axial offset passes because it has to do with some other style of cutting like gear teeth and other types of things. It just, the way it cuts, it's just a different type and it's going to add a tremendous amount of time onto something like this. It just doesn't apply to relief style cutting. Up and down milling, both is fine. It's just a path that it goes. It'll be just fine. Stock to leave, we're not going to need that like we did on our first bit, because on our first bit we needed to leave some for our next bit. Now if you're going to run another bit after this, then you want to check this and add a little bit left over. If you remember on the first bit, the 1/4 inch pass, the roughing, we left a 1/2 millimeter. So if we run, say, a 1/4 inch bit that first time we did, and then say we run a 1/8 inch flat end mill and run that on another pass doing this same morph here, what it's going to do is it's going to run all down and it's going to get everywhere a 1/8 inch flat end mill can fit. Now, a 1/4 inch flat end mill is not going to be able to fit in a lot of spots. So that's going to remove a little more material too. You can do that as well. And then make sure you leave a little bit here so that when you add another tool path that you'll have something to cut away. It's the same thing. And you can just keep stacking tools on here, as many as you want, as long as you keep leaving some material left over for each tool to cut. So based on that knowledge, we'll move on. Fillets, we're not going to mess with the fillets because basically there's no fillets on here because this is a relief. Fillets are where you have like a square object and then the edges are kind of rounded over or whatever. You know, it's kind of like that edge there, and you can machine that areas that a little different by checking that fillet box there. We don't need it, so we're gonna move on. Smoothing, just like before, we want that because we want to try to make this as smooth as possible and look the best. Same with the feed optimization. We want to check that because we want our bit flowing around here as smooth as possible. We don't want it just going balls to the wall, ripping around here as fast as it can go without no mercy. We want it to be able to come to a spot, and if it needs to slow down, we want it to slow down. So you check this. And I would leave all these default settings because they're pretty good. Go to your linking tab. Really don't have to worry about anything on here. All the default settings on here are absolutely fine. And that is pretty much it for our Morphed Spiral on our finishing bit. So we're going to click OK. And then we're going to sit here and wait. This is probably going to take about 5 minutes or better for it to figure this out. So let's watch. Okay, and now it's done. So based on that, you see that it had done everything that you can see. Looks pretty decent. So let's, as before, we'll go up here to the Simulate tab. We'll click on Simulate. Might take a second to roll up on here because that's a lot of detail on there. So as we're waiting for this, you notice that it did the outline too a little bit. We probably could have made that a little bit smaller. That would have saved a few minutes, but not too bad. So as in before, you know, you have your display. This displays your tool path, your stock. Make sure you got your stop on collision. Go to your info tab, you scroll down. You notice it's calculating down here on the number of collisions that are in there. It hasn't found any yet, but it's only 13% done. So you can see some other information on here in your statistics and everything else. So if you want, you can come over here and you can hit the run. But see, if you notice, if you look, you'll see this is exactly where it left off before. Just like how it's going to look on your table after you get done running the first tool. So we'll hit the Simulate button. And you'll notice it comes down in here. And let's scroll down in here a little bit. And you'll see that it's actually removing just a little bit, and it's going around in a loop, and it's getting bigger and bigger and bigger. Excellent. So let's scroll out a little bit. If we scroll out a little farther, it'll go faster. And we'll speed it up here a little bit. Actually, we'll speed it up all the way. And you can see it. It's just hammering away here. But if you notice, let me turn it here so you can see it. It's starting to put the detail in there. And that's what you want. That's the prize at the bottom of the picture. Let's go back to our info tab here and see where our process is going on. See, it slowed it way down when you're simulating because it's really chugging trying to get this to simulate all here on my laptop. So basically we saw that part. So we can pause this out here. We don't need it to run anymore out here. This is what we're more concerned about here. Let's let this collisions run and see if we've got any collisions. And if so, we're going to have to fix them. Okay, now you notice that we didn't have any collisions. So that's a good thing. And I also fast forwarded the simulator here so you can kind of see what it looks like when it's all done here. Looks pretty good. I like it. It's exactly what that baby's going to look like. So let's go ahead and close the simulator because we didn't have any problems. Back to our home position. Now, we've got our two files here. We're going to take these and we're going to save these to our hard drive. First off, we want to select the first file. Right here. That's our additive file. If you notice, it says 32 minutes. It's going to be a little longer than that. As of right now, it's probably going to be at least twice that, if not more, because Fusion has taken all the rapid feed rates out of your tool paths until you buy it from them. Well, I'm not buying Fusion 360. I mean, I would buy it if it was just a flat rate, but since it's a monthly subscription, I can't justify that kind of money. So I'll just use what I can out of it and move on. So what you can do is you can add your rapid feed rates in later, and I'll show you how to do that after this. So we go on here, we select our first one. We go up here to see where our simulate one was. Right next to it, it says post process. And if you installed the post processor properly, then when you click on this, you will have your post processor on here. It'll say Snapmaker on here. And then, so if you start from the top up here, your configuration folder, that's where the post should be at. That's where your post should be. You pick your post name from here if it's not already in there. The next one down is going to be where this file is going to be put at. So where it's going to be saved on your hard drive. Right here is the extension it's going to have. It's going to have a .cnc. If you come down here, here's the name. So on here, I'm going to write small bears, and then I'm going to put an underscore, and then I'm going to say 6mm flat end mill, and then I'm going to hit post. You can fill in something else if you want here. This is just basically for comments, and you know, everything else is pretty self-explanatory. So we're just going to hit post. And it's going to want to ask you where you want to save it at. So I'm going to hit save. And that's that one. Let's go to the next one. The next one is this one right here. That's going to be your finishing tool path. So we're going to, because you can't do automatic tool path, you know, changes in your Snapmaker machine because it doesn't have it, so you have to manually do it. So you're the manual changer. You're the automatic changer. That's you. So in order to do that, you have to have a separate drawing or a separate tool path for each tool that you use. And you just do them one at a time. So right here's the second one. We're going to take this tool path that's highlighted, go up here to our actions. We're going to hit post process. Just like before, we're going to come down here and I want to select this as bears. Whoops, I'm sorry. I want to say small bears. And then I want to do an underscore, and then I want to say final. So this is, I'm doing this so that when I look at the file itself, I'll know what to do with it. I'll know this is the final, and I will also know that this is going to be a 1mm tapered ball mill. And I don't need anything else. So I'm going to hit post. It's going to come here and want to ask me where I want to post it again, but it already picked it, so I'm just going to hit save, and that's that. We are done with that. So you can close. Well, I'm sorry. You want to save all this if you want to have this for later. But the files you just made that you saved, if they're done correctly and everything works out right, you just save those. Those are the ones you'll reprint over and over and over again. Or you can come back in here and go back to your design, come in here and change the size. Once you change the size, you go back to your manufacturers tab. When this comes back up, you'll get back here and there'll be a bunch of errors right here because you changed the size. So basically all you're going to do is just right click on each one of these and you're going to select generate. And what that's going to do is going to regenerate that based off all the changes you made prior. Just go right down the list, generate the first one, right click on the second one here, go up here and click generate. Then you come down and you right click on the last one and you click generate right here. If there's a problem in here and it's messed up and you don't like the way it is, all you got to do is go back over in here, right click on here and select, go to the very top and select edit. When you select edit, it's going to bring that tab back up again to where you first set this all up, and you just go through and make your changes to whatever you need to do. And then once you're all done, then you select OK, and it'll run back through it. If there's any changes, it'll make the changes and you'll have new pattern in here and everything. And then you'll have to regenerate your last one because that'll be different. Just keep going down the list. Wherever you make a change at, you have to regenerate everything after that change, or else it will still be set up as the old way. So since I got all this done here, I'm just going to hit my save. This is where you can save different options. It'll ask you a little thing here like what's the deal, and I'm just going to say final version, because this is my final version and it should cut all right as far as I'm concerned. I'm going to select OK, and it's going to save all that happy stuff. Okay, there. Now what we can do is we go in here and we can fire up our Luban. And I'll take the Luban and I will turn on my Snapmaker machine. Now my Snapmaker machine's on and booting up. While it's doing that, I can load the files in here. So let's go to our, let's go to our workspace. Over here where it says open G code. You can open this code up here. Go in here where your file is at. We had a small bears 6mm flat end mill. I should have put roughing in there, but I didn't. I forgot. So we'll take that one and we'll say open. And there it is. And you notice your start's down here in the corner. It doesn't matter where this is at on the screen, just as long as it starts right here in the corner. Okay, we've just loaded that up in here. Our Snapmaker is all booted up now, so let's connect to it. We'll go up here and click our refresh button. And notice the Snapmaker didn't talk. I'm connected here. Where's my Snapmaker? There it is. We'll connect to it. It's going to want my screen authorization. I'll reach over here and I'll click the yes. It's going to want a home because I just turned it on. So we'll home it. I personally, when I get long relief cuts, especially when they're going to take hours at a time, I'm going to move those files over to the Snapmaker and run them on the Snapmaker. If it's going to be something short, 20 minutes, half hour, if I'm going to be sitting here in front of the computer the whole time or whatever, you know, then I'll run it through the Luban window. Otherwise, I do it the other way, just in case something happens with the computer, it decides it's going to update or download something, or a pop-up's going to come up or something. You don't want nothing interrupting this, because then you might lose control of your machine through your computer. So whenever I get long runs, I run them straight off the machine. That way, there's no problems. The machine runs, you still got control over there. You don't have to worry about your computer mysteriously booting in the middle of a cut somewhere. So, based on that, we've got this here. All you got to do is reach over here and select this send to device. That's if you're connected to the Wi-Fi. If you're connected through your USB, you can do it that way. You can also transfer them, copy them over onto a USB stick and stick it into the machine, and you can copy them over that way. Now the Snapmaker is asking me if I want to start it now, and I don't want to start it now. So I hit no, and then I'm done with this here. I can close this out. Let's go bring our other file in here. We're going to open. We want the small bears final. We're going to open. Here it comes. There it is. And you notice it's in the same spot. You notice your start's in the same spot. Everything's in the same. We are also going to send this one over to the Snapmaker. And once it gets there, I click no because I don't want to run it yet. For demonstration purposes, I'm just going to do it through the Luban here and show you what it looks like through there. I won't run the whole job and show you. I'll just show you bits and parts and fast forward through the rest. So what we're going to need to do is let's get out of this one because we want our roughing first. So we get out of there. Let's go up here. Let's load our roughing. Here's our roughing. We want to hit load into our workspace. There's our roughing one. Now that we're loaded up, we need to set the home position. So in order to do that, you're going to go and move these around and move your head around and get it set up. Once you get it all set up and ready to go, you come up here and you click play or run and watch the excitement, because it'll start ripping that wood right up. But keep an eye on it. Sit here, especially if this is your first time ever doing this or anything, and especially anytime you do anything new, because you don't know what to expect. I always watch my very first job of whatever I make. I always watch the entire process to make sure there's no surprises somewhere in the middle of the job that I don't know about or that I missed somewhere. You never know unless you sit there and watch it. If you watch the whole thing, then you know that it went all successfully and everything went well and there's no issues. You could leave it alone the next time and not worry about it. Just set it up and let her rip. So we'll get her all set up here and then I'll show you what it looks like. Okay, now what we're going to do is we're going to set this up so we can cut this with a 1/4 inch bit. Quarter inch bit, flat end mill. 1/4 inch ER11 collet, and then the nut. You want to take this and put this in here, cone side in this way, push it in there so that you hear a snap, just like that. Stick it up in here, put your 1/4 inch end mill in there, go all the way up, and then come down just a little bit. Tighten this up. You don't have to make it super tight, but make sure it's tight. Okay, now that you've got that done, now you want to move this down into a spot where you can do your zero at for the z-axis. So what I'm going to do is I'm going to make a little mark right here. That little X marks the spot right there. That's where I'm going to do mine at. And I'm going to use a 2/1000 feeler gauge. So I'm going to move this down and move it into position here. Well, actually, first, what we should do is we should set the perimeter. So, as we're setting the home here, we can easily go in here and adjust the home. So we'll go right there, and I'm just going to do a test, or not the home, but the work origin, I mean. So we're going to do a test here, and I'm going to set the work origin right there. We're going to move this so we can make our home position and our 0 point on our material. Okay, so what we got here is I put the head right here, and in Luban I ran the boundary on there where it says run boundary, and it ran all the way around, so I know it's going to fit on the piece of wood right here. So I set my 0 points right here, even though it's up in the air, because it doesn't matter yet, just as long as all your zeros are right here. That way, when you go to set the point where the top of your wood is, you still have your 0 point set over here, because all we got to do is just change the Z over here. So, this is what we'll do. We will move this over to our spot. That was 10, now we're down to 1, and that's almost there. Let's move this here so we're over our square. Okay, right there is over our square. Make sure you don't push on your plate, because you can move your table up and down in the east and the west, or I'm sorry, in the Y direction. You definitely don't want to be leaning on here when you're doing any of this. So make sure that you're not leaning on here, you're not pushing. Put your feeler gauge on there, or whatever you're going to use to set the height. And we're going to lower this down so it's just snug. When we get close, we'll break it down to 0.1. And I want to be able to feel that on there. Right there. Okay. Once I get to that point, I'm going to click either in Luban, you can click the little Z box, and you click down at the second option, which is to set the 0 for the Z only. Or if you're on the actual Snapmaker itself, on the console, it has a button on the control panel there for the movement where you can just set the Z origin. So that's what you want to do, just the Z origin. Okay, now I have that set to 0. Move my feeler gauge. Go back to where my controls are at. I'm going to move my head, my Z axis here. I'm going to move that up 10. And then I can move this back over here. Move this back up over in this area somewhere about where the home position was at. And then all I got to do is say go to work origin. I'm in my work origin. Now what I want to do is lower my head or my Z axis 10 right there. Now that is the actual top of your material and you are in your home spot. So now that you're at that again, go back over, set your Z origin only back to 0 again, or you can just hit the set work origin right here. It really doesn't matter. Either one works just as good because you're in your final position. Now you're ready to go. Run your job. Okay, now that we've got that done, now we need to change bits. So let's take the 1/4 inch bit out. Make sure you hold on to it so it doesn't fall out. I'll loosen this all the way up. Let's take our 1/4 inch collet out. We're going to put an 1/8 inch collet in. Make sure there's no sawdust and stuff in here. Put it back in there. Listen for the snap. If you don't hear the snap, it's not in right. I'm going to put this on here. Here is my 1mm tapered ball end mill. I'm going to put that in there. Here's a good thing to do. You know how deep your drawing is? You can stick this in here and you can see how far you need to go with your tip. You can see I'm almost to the edge of the painted part, or the coated tip there. So as long as I've got at least that much sticking out, I should be good. That I know will put the top of it up near the top of here, so as long as you got most of that in there, you'll be okay. We're going to tighten this up. And just as before, we have that little mark here. Got our feeler gauge. Let's put our tip point right on that little spot. Just like before, we'll put our feeler gauge in here. Bring this down, get it close. Don't want to jam it into your material here. So put it on the smaller so you can feel it. And I don't mean you just want to just barely feel it. You want to feel that sucker grab onto that. Not to where you can't move it, but just, you know, where it's got a lot of tension to it. Pull that out. Just like before. You want to go and you want to hit your set Z origin only. If you're on the Snapmaker machine, it's on the control panel where the home and the set work and the set work origin stuff is at. There's a button on there that says set Z. Push that. If you're on in Luban, there's a box to the right of your access coordinates. One says Z on it. If you click on that, the second set of words, the second sentence in there says set Z to 0. That's what you would click. And that would set your Z to 0. Because we still have the X and the Y set to 0 where our start position is at. As long as you didn't change any of that stuff or hit that set work origin by accident, we're still good to go. So what we'll do is we'll go in here and we will raise that tip up, the head here, going to raise it up 10. Then we're going to move it over close to where our start is. Once you get it close to there, then you can push the button that says go to work origin. There you are. There's your start. Now all you got to do is click run. Now all you got to do is clean it up, pull it out of here, dust her off, and there you go. That's how you do relief work in Luban with tool changes through Fusion 360 on the Snapmaker. It's pretty awesome. It's pretty deep. It's very detailed. Very good. Good luck, and I want to see some great projects out there.